All right, let's get going on today's meeting. So, what we're going to be doing today is we're going to start our look at perception, and we're going to be sticking with perception for a few weeks now, because one thing is that it's very important to understand perception and how it works and how our mind achieves it, because it's the way that we get external reality into our representational system. So we kept talking about how things went from external reality into your representational system. Perception is that bridge that allows us to do that. And historically, perception is very important to cognitive psychology because it was one of the first major areas that cognitive psychology made really important contributions to our understanding of behavior. So, when cognitive psychology first started out, one of the areas that it really achieved success in very early on and made people convinced that this is a viable way to understand the human mind was in perception. So, we're going to start our look at it today as we continue on with our attempts to understand the human mind. And what we're going to look at today is to understand the representational level of how we do things where we perceive information in our environment and then are able to interact with our environment in that way. So things that allow us to do play a game like hide and go seek, do that visual search where we're searching for a target, things that allow us to navigate through an environment without running into a tree or running into a park bench. Well, how is it that we accomplish those things? That's going to be the focus of our time for the next couple of weeks. So that's what we're going to start up today. But before we get there, we are going to do just a really quick change detection wrap up. We had a really great discussion last time about the implications of change detection for racism and sexism and other ills in our society. And that's one of the common themes that I keep wanting to come back to in this course. Just as a sort of really quick aside, a lot of times when you encounter phenomenon in this course, when you encounter concepts in this course, when you encounter the way that our minds work, a lot of the times you will be exposed to that initially in laboratory settings, in experimental settings, and those settings are very controlled and oftentimes very contrived and oftentimes look for very small effects. And the reason for that is because to a scientist, small effects can tell the difference between, oh, our visual system is using this one strategy versus using strategy B, right? So these little differences are what scientifically and logically allow you to conclude, oh, this is a representation that we're using. This is how our mind works. And this other theory, this other representation is not how our mind works. However, sometimes when you just focus on that, you lose sight of the bigger picture, which is what can we do with this information and how is it important in our application to the real world. So this is one example here where we took a look at a bunch of different instances of change detection. You did a cog lab on change detection. And if we leave it there, it again remains this nice little parlor trick that you can maybe fool your friends with, the next time they're over and everything crashes and all you have is your access to cog lab. You can go to your friends and say, hey, you want to check out this change detection cog lab? And they might be interested in it for about 5 minutes before they're on to real things. However, these cognitive effects, these cognitive processes, these representations that we have real world impacts. They have real world implications in terms of how things occur in our world. And understanding those connections is the first step in understanding how to change those things that we are not satisfied in the real world. So when we understand how humans work, how our minds work, that leads to certain things in the real world being the way that they are, we know where that connection is and we know where we can put our leverage to change those things rather than being well-meaning, well-intentioned, putting in a lot of effort in the wrong area and not affecting any change. So we're going to talk about that just as a change detection wrap up. Then we're going to go and start right at the basic idea of what exactly is perception. And we are going to end with an extended look at top-down versus bottom-up processing, which was a debate in a very heated debate in perception history for a very long time, where people were either on one side or the other. And we're going to take a look at the evidence for top down, the evidence for bottom up, and come to a sort of understanding of a both and situation and how our minds work. All right, but before we get to perception, we are going to do our change detection wrap up. So if you recall, last time we took a look at change detection in real life interactions, and we talked about the Simons and Levin experiment with the door frame and switching out the experimenter. And we mentioned that when they did this experiment, they found an age effect. So basically, if you were younger versus if you were older, if you were younger, the young subjects, 20 to 30 years old, they noticed the change in the experimenters 100% of the time. However, the 35 to 65-year-olds did not notice that change ever. All 35 to 65-year-old subjects did not notice a change. And the experimenters wondered whether that was an age effect. So maybe we just get worse at change detection as we grow older, or did it have something to do with the fact that the experimenters themselves, the people that were switching with each other in this experiment, they themselves were in that 20 to 30-year-old bracket, or at least close to that 20 to 30-year-old bracket. So what they did is they said, okay, well, let's think about whether this is maybe an in-group versus out-group effect, or if it's an age-related effect. So they effectively took themselves out of the student in group. So they made themselves no longer belong to the student group, and instead they put themselves into an out group of construction workers. So now they did not belong to the student group anymore, which was the subject pool for this experiment. And when they made this change, the 20 to 30-year-olds who previously noticed 100% of the time that the experimenters changed, now they only noticed it 33%. So it was a marked decrease in how often this change was detected. And this led to the theory that we are much, much more likely to notice a change if a change occurs between two people that are in our in group, the group that we belong to, that we self-identify as, that we feel is the category that we're in. Whereas if the change is made in somebody in your out group, somebody that you don't feel belongs to the category that you classify yourself as, the identity that you have, you are much less likely to notice that change. And what that basically means, it basically means that when you are processing these individuals, when you are first encountering these individuals and they start asking you for directions, to someplace on campus, if they're an in group, you process and you turn your attention to them and you process way more information about that individual than if they're part of an out group. So if you're a student and a construction worker asks you for directions, you don't process very much of the information about that individual. You don't go through a lot of steps in either serial and parallel processing. The point is you don't process a lot of data, a lot of input from that out group person. But if it's an in group person, then you process a lot of data that is coming from that in group individual. And that's why you notice a change when the change occurs in an in group, because you processed a lot of information so that when the change is made, the information does not match up with the new individual. But if you only process a little bit, such as male wearing a hard hat, Caucasian, when the change is made to another male wearing a hard hat, Caucasian, you have no information to notice a difference and you don't detect that change. So the discussion that we had, it was a really good discussion, is how this might affect racism, sexism. We didn't get to the fake news or conspiracy theories. I'll leave that to your own cognitive reasoning. But we mentioned that you're more likely to notice that in-group versus out-group change and how that is because of that information processing. So how does this relate to racism? I just wanted to put a pin in this because we had a really good discussion, but just want to kind of summarize what it all meant. And also wanted to use this image from Scott McCloud, So Scott McCloud, the little cartoon guy there in the bottom left, he wrote a book called Understanding Comics, which was one of the first um, academic works that really said, hey, you know what, let's try to understand this medium that millions of people have enjoyed, that takes pictures and words and puts them together in a way that our minds can understand. So in our world of psychology, people can read comic books, computational level. How are they doing that? What's the representation? How is that implemented? That wasn't even a question for researchers until people like Scott McCloud started doing it in a scholarly and academic way. In this image here, in this panel here, he is making the point that cartooning is very effective and can help to portray a story and can help to involve a reader in a plot or in a story or in a comic book, because you are focusing on specific details. And he emphasized that you're not so much eliminating details, but you're focusing on specific details. But in reality, you're kind of doing both. You're determining which details you're going to eliminate and which ones are the important ones that you're going to focus on. And what you can do is you can take an individual like that man in the upper left there, and you can draw them with a certain amount of detail. And the point of that image is that image right there is about 5 people in this world, right? Maybe 10. So as I look around this classroom, that person in the upper left-hand corner, they're not in this classroom, right? I have enough information in that image, and I have enough information from everybody in here to realize that that person is not in this classroom. And if I walked outside, I probably would not encounter anybody today that fits that description. However, if I abstract a little bit out and put in less information into this image, you end up with an image like this. Now you compare the two and you're like, oh yeah, that's the same person, now drawn in a much more cartoonish way. Much less information is there for you to process. And now, instead of this only being 10 people in the world, this could probably be 10,000 people in the world. And if I was told to be on the lookout for this individual as I was walking around today, I would not be surprised if somebody that fit this description, I was encountering somebody that fit this description. And you can abstract that even further. So this is a large proportion of our world would fit this third description. Still looks like the same person, but now at a higher level of cartooning and abstracting. This is like a vast number of people fit this particular level of abstraction. And then this final one here, this is everybody, right? Everybody in this room fits this description, especially if you take your glasses off. But this is basically every single person in this room, every single person that I'm ever going to encounter. And Scott McCloud's point is that when you strip that away, you can amplify certain meanings. And then it's also very much easier to identify with the other, with the cartoon represented individual, because that last person could be anybody, including you. So sometimes when you abstract in a cartoon way, it allows you to immerse yourself in the story a little bit more, because you can see more in common with the individual because there's less details to be in common with. All right. So why am I showing you this? Well, we're not going to use it in terms of an idea of cartooning, but we're going to use it in terms of an idea of how much information are you processing? Because if you go through a lot of information processing, you end up with a perception, you end up with an internal representation of the person that is all the way to the left. And that is a very unique individual. But if you go through less processing, then you end up with not so unique an individual. And if you go through the minimum amount of processing, you end up all the way down at the right there, where you know you're talking to a human being, but they are not an individual human being. They're part of a category of human being, but there's no individuality in that last person. So we have this individual here, highly processed. We have an example of the same individual down here. Very little processing has occurred. So we got on the left there, massive amounts of information has been processed. On the right there, very little information has been processed. And the reason that's important and the reason that ties into this change detection and racism is because if I now swap out these images for a new individual, if I now swap out these images for a more detailed image of Scott McLeod, you will notice the change on the left there, right? So if I swap between these two images, you will notice the change on the left. You'll be like, oh yeah, that's person number one. That's Jim. I'm going to give him the name Jim, and that's Scott, right? There's Jim. There's Scott. I noticed a change. However, if you have shallowly processed that information for these people's identities, if you have not put attention and use your processing resources to process, I keep saying processing, it's like cinnamon. If you say it enough times, it gets weird. If you have not put enough attention to process that information, you're not going to notice that change. So I am actually changing the face on the right as well. It's just that it's at such a low level that there literally is no change between the two. So what does this mean in terms of racism and in terms of impacts that it can have on how we relate to other people, how racism might propagate in our society, even against things like sensitivity training or people being educated about it in certain ways? Well, the reason this is important is because when you encounter a person, and we're going to see this when we get to categories later on in this course, but one of the things that a category does, it is allows you to know how to interact with a particular person, right? So that's one of the reasons why gender is such an important category, because in our society, you interact with males differently than you would with females. You interact with transgender individuals differently than you would with non-transgender individuals. It's a very important category and becomes massively important, for example, if you go to the doctor, right? So if you go to the doctor, it is very important for them to know your gender, and because there are certain things that happen to males that do not happen to females. There's certain complications that can happen with a female that does not happen with a male. You need to know these categories. So if I'm processing this individual, I might first process that they're male, put them in one category. I then process that they're Caucasian, put them in a subcategory, male Caucasian. If I process it enough, I'm going to get down to the fact that this person is Jim. And what I know about Jim and how I know to interact with Jim and how I know, even if I don't know that this person's name, how I know how to interact with this one particular person has to be approached from the perspective of this is a particular person, right? So I don't apply everything I know about all males to this particular person because this is Jim, right? This is a single male. I don't apply everything that I know about all Caucasians to this single individual person because this is Jim. And my processing of Jim is going to mean that I treat him differently than I do Scott. So if I ever met Jim at a academic conference, I would walk up to him and I would say, hi, my name is Dr. Yurichevich. And he would say, hi, my name is Jim. I'd be like, well, it's very nice to meet you. What brings you to this conference? Are you presenting? Are you, do you have a talk coming up? What areas are you interested in? That's the conversation I would have with Jim. If I saw Scott McLeod at a conference, I would have to stop myself from hugging him. I would probably be fangirling all over him. I would say things that I would regret later on for sure. But the interaction would be very different because that's Scott McLeod. He's a very different category for me. And I processed enough information to know that that is Scott McLeod. However, if I don't process Jim, if Jim is an outgroup, then that's how much I process the information when Jim comes and meets me. And if Scott is an outgroup, then that's how much I process their information. And they are no longer individuals. And because they're no longer individuals, our minds no longer treat them as individuals. So if I want to know how to interact with this person, I need to basically generalize to the category that I can fit them into. And if that generalization is only based on race, then I treat them according to whatever type of stereotype or theory I have about the entire race. So and that is basically racism, to basically say that this one individual is going to be the same as what I believe everybody else in that group is, right? So that idea of not processing that information enough to get them to the point of an individual, as we see in change detection, that allows us not to treat them as individuals. In our minds, they're not a single person, they're just a member of a group. And if we have bad ideas or wrong ideas or discriminative ideas about that group, they're not going to be applied to that individual person. They're not, sorry, they're going to be applied to that individual person rather than our ideas overriding it because, oh no, that's Scott McLeod and he's a very different individual and deserves to be treated as an individual rather than generalized and treated as if he's part of this homogenous larger group. All right, so that's the wrap up for change detection. So again, as we're going through this cognitive psychology course, it gets very dry and it can get very tedious if you kind of keep it in the lab. So one thing that we're going to try to do on a regular basis in these class meetings is get it out of the lab and see what does this actually mean for how we interact with each other and how we behave in the real world and implications for the real world. So as part of the study strategies that we mentioned last time with elaboration, I would encourage you to do that as you read through. Because everybody has different experiences, everybody has different histories that they bring to their reading. So when you're going through this, try to think to yourself, oh, have I ever encountered a situation where this might have explained what happened? Or have I ever heard about or read about, different theories about how the world works or how, relations between peoples work, how economies work, how fake news works, how any of these sort of things that are occurring in society, how social media works, how things go viral, whatever it is, try to make these connections because it's one way to elaborate and help you understand change detection, for example, a little bit better. But it also makes what we're doing here so much more important. Because if you don't see the connections of this to the real world, then all I'm really doing is teaching you trivia. And that's not what we're trying to do. All right. So that was our wrap up of change detection and attention. We are now going to move on to perception. So we're going to start off very basic. What is perception? So the base definition of perception is that it's experiences that result from stimulation of the senses. So experiences, some sort of internal cognitive sensation. I don't want to use sensation or experiences. Some sort of internal cognitive event that is resulting from the stimulation of your senses. So an example of that will be shown right here. So in the external world, in the real world, there is a rabbit, and that rabbit is reflecting light, and that light is hitting your eye, and that stimulation of your retina by the light that is entering your eye causes an internal sensation that allows you to see this particular external reality. You have that experience of seeing a rabbit resulting from the stimulation of your senses by the light that the rabbit reflects. So that at its basis is perception, and we need to differentiate this from experiences with no stimulation of the senses. And this is what is known as hallucinations. So we're not going to be talking about hallucinations in this course. That is an abnormal psychology topic. However, we need to be aware that unless you have that stimulation of the senses, it falls outside of the realm of perception. So it falls outside of the scope of what we're going to be looking at. And an example of that is the 1950 American film starring James Stewart called Harvey. And it's about a man named Elwood whose best friend is a 6 foot, 3.5 inch tall, white, invisible rabbit. So white invisible is a bit of a contradiction in terms, but again, it's a hallucination. So here's.
Is this all right? You sure? Well, I'll give you a hand. Whoop it, don't slip. Now, you're sure this is all right? You wouldn't rather sit in the booth? Well, all right.
Would he prefer a booth, Mr. Dad?
Oh, thank you, Mr. Cracker. He seems to prefer the bar today. Well, good afternoon to you, sir. Hi.
All right, so he just invited Harvey to sit down on the stool next to him, and you could see the reaction of that other bar patron. And clearly, there's nothing there. Clearly, there was no stimulation of the senses, and that's why he had a surprised look on his face. So that's a hallucination. And again, that is part of cognitive psychology because it is that computational level. Some people do hallucinate. However, it is in the realm of abnormal. So we will not be taking a look at that, but just keep that distinction in mind. We're talking about things that occur, internal experiences that occur from the result of stimulation of the senses. If there's no stimulation, then it's not part of perception. All right. So we have that basic working definition of those experiences from the stimulation of senses. And even though we're not going to talk about hallucinations, when you perceive something that is not there, it's important to realize that we are going to talk about times when perception is correct and where perception is incorrect. So perception can be correct. So when we took a look at that video of a rabbit, the external reality was that a rabbit was actually in that field. So that is the external reality. And what we all perceived was a rabbit that was in that field. So in this case, the external reality matches our internal experience. And in that case, perception is classified as correct. We've correctly perceived that external reality. However, perception can also be incorrect. So you can get stimulation of your senses. So this isn't a hallucination. You can get stimulation of your senses from the external reality. And at the same time, that stimulation leads you to the wrong internal experience, or more accurately, an internal experience that does not match up with that external reality. So one of the ways that you can illustrate this is through illusions. So I'm going to show you a classic illusion. This is called the Mueller-Lyer illusion. And so it's here right now. So what I would like you to do is indicate by show of hands how many people perceive the top line as being longer than the bottom. So show of hands. All right, we got a few. How many people perceive the bottom line as being longer than the top? All right, how many people perceive them as being the same length? All right, awesome. I have a very, very truthful class. Sometimes when I ask this, I ask people how many see the top line as being longer, and nobody puts their hand up. And how many see the bottom line as being longer, nobody puts their hand up. And how many see them as being exactly the same, and everybody puts their hand up. And it's really, really reassuring that everybody here understood the term perception. Because unless you did not have this experience in intro psychology, or maybe didn't see it in some educational YouTube video, just about everybody knows this illusion. It's a very famous illusion, and it should come as no surprise that those two lines are actually exactly the same length. So those two lines are the same length, yet we perceive that top line as being longer than the bottom line. So that is incorrect. And this is an example of our perception being incorrect, because instead of seeing this, what we actually perceive is something closer to that, where that top line looks longer than that bottom line. So this is a case where we have external reality being one situation, and our perception of that external reality is different. And you will find as we go through that cognitive psychology is obsessed with when things go wrong, right? So just about every experiment is trying to set up a situation where your mind does the wrong thing, or makes an error, or basically does not match up to external reality. And we'll talk more about this as we go through the course, but one of the big reasons for that is because when our minds make errors, that gives us some of the best clues in terms of what's going on inside. So it's only when the system gets pushed beyond what it is able to do, and only when the system, your perceptual system, for example, fails in matching that external reality, that we start to get the best clues in terms of what's going on inside a person's mind. So if you're wondering why a lot of the cog labs, might feel a little bit difficult, so the change detection, there were definitely difficult situations in the flicker condition where it was difficult to achieve what seemed very simple in the non-flicker condition. It's because they're set up that way to show the limits of where our minds actually break down. Once you know where those limits are, you have very, very good clues in terms of what is actually going on inside. All right, so I'll show you another illusion. So this is a picture that was taken, I believe it was the actual Abbey Road. So these are the Peanuts characters, and they have been drawn as crossing that very famous road. So this is, it was based on the Beatles album cover for Abbey Road. So when you look at this, you probably have a internal experience from the stimulation of your senses that is a situation that is very much like this. So 4 upright characters walking across the road, 1 upright character, Woodstock on the right there, flying across the road. But we have these upright individuals, almost as if somebody took wood cutouts and painted them and then mounted them on the road, took the photo, and parodied the very famous rock album cover. If you take a look at the picture from the Abbey Road album from a different perspective, so this is a behind the scenes shot of it just before they took the photo, you get the correct interpretation. You get the correct interpretation that they are upright individuals, right? So the Beatles are walking across and they're upright, walking as you normally would. You get that same impression here. You get that same internal experience here. But how many people are aware of the actual external reality of this? Mm-hmm. All right. So the guess is that it's probably a painting on the road that uses forced perspective. And I love that answer for 2 reasons. Number one, you're right. It is a forced perspective painting that is actually on the road. It's not vertical at all. But also very telling was your use of the word probably, because you still perceive this as being upright. And you're like, well, you're showing it in a class, you're talking about illusions. Of course, it's not going to be the actual thing. It's probably something else. But it's very difficult to actually see from this perspective the external reality, the true external reality of this particular illusion. So let's move this over to the side a little bit, just in case anybody can't see it. So if you got Marcy there, that's the perceived upright version of Marcy. Then over there at the bottom is the forced perspective painting of Marcy that is on the road. It's flat on the road. And if you take a look at where her nose is, there's the relation between her nose and the perceived upright orientation, and then her nose on the road. She's got her hand right there. She's got her foot right there. And basically the way that this works is that the things that are closer to you are drawn smaller on the road. The parts of her body that are further away on the road, they're drawn larger. And that information gets processed by your visual system so that instead of seeing a flat image on the road, what you see is an illusion of an upright image that seems to be coming out of the road, standing up, much like normal people do when they walk. So here we have an example of an external reality. That's the actual external reality. That is what is actually out there in the real world. That stimulation from that stimulus comes to your senses and somehow gives you the perception of upright cartoon characters walking across this road. So again, just to drive home the point, sometimes your perception will get things wrong, such as in illusions. Sometimes it'll get it right. Most of the time, it will get it right. The fact that we are able to survive in our world, the fact that we are able to navigate and be successful in this world means that most of the time your perceptual system works as it was designed. It works well enough to keep you alive, to keep you moving forward, sometimes literally. It's another one of these examples where your mind is as good as it has to be and as lazy as it can possibly be, because our perceptual system is good enough for us to survive, but not good enough to solve illusions like this, because again, this illusion was designed to push our perceptual system to the edges so that it basically crosses over, it fails, and that again allows us to find out what the limits of our perceptual system is. And that allows us to come up with those possible representational strategies for how this could possibly work. All right, so any questions on illusions and what perception is in general? All right. So we are now going to move to top-down versus bottom-up processing. So in the history of perception research, not so much anymore because of information that we'll see in just a little bit, but in the history of perception research, this was a very, very hotly debated topic. And you would have perception researchers that were split into two camps. And one camp would be the predominantly top down, just about all visual processing is top down. Another camp would be the predominantly bottom up, all perception is bottom up processing. And the two would get into arguments, they would get into battles at conferences, entire streams of series of experiments would be done and published to try to prove one side, entire series of experiments would be done to try to prove the other side. If you changed your mind, it was almost sacrilegious, to defect to the other side. So keep that in mind as you read. Sometimes, if you read historical from the 1900s, if you read papers from the 1900s on perception, you'll get this strong sense of it's either one or the other. It's all or nothing. Today, we're going to see where it's sort of what is the determining factor about whether or not it's going to be top down or bottom up. It's never all or nothing, but it does, your perceptual system does go on a spectrum from mostly top down to mostly bottom up. So let's start with bottom up processing. So bottom up processing is basically where the information for perception comes from the stimulus itself. So it's called bottom up because the stimulus is considered the bottom. It's considered to be the bottom of the perception chain, if you will. I know chains don't have bottoms, but the bottom of this perception skyscraper, I guess, it's where perception starts. So perception starts with sensation in your visual system that comes from the stimulus, and bottom up processing basically says that your information for perception comes from that stimulus itself. It comes from the bottom. Now, this by definition has to be true, right? Because if you're not getting stimulation from a stimulus, you're hallucinating, and that's not perception. So the question isn't whether or not this does occur. The question is, how much of perception is bottom up? How important is this bottom up processing, and how much needs to be added to it for from top down processing? But before we get to that, let's take a look at an example of bottom up processing. So I'm going to show you an image, and I would like you're going to see an image with two. That's not going to be too much of a spoiler. You're going to see an image with, I spoiled the whole demonstration. You're going to see an image with a certain number of animals. And I would like you to tell me, how many animals do you see? All right, here we go. All right, so does anybody see two? Okay, does anybody here think the fact that I spoiled this demonstration by saying I'm going to show you two animals helped you see two animals here? So this is an example. I didn't ruin my entire thing. This is an example of bottom-up processing. So your ability to see two horses here came from the stimulus itself. And the information that I gave you didn't help you in any way. You were able to see that there were two animals there. And in order to classify them as horses, yes, you have to draw on previous knowledge. In order to classify them as animals, yes, you have to draw on previous knowledge. But the idea is that if I showed you animals that you had never seen before, you would still be able to see, oh yeah, those are two. So if I went to a cross-cultural place somewhere in this world that had never seen a horse, and I said, I'm going to show you an animal you've never seen. You tell me how many there are. I show them this picture. They might say, I have no idea what that is, but there are two of them. And I can tell that because of the information coming from the stimulus. All right, so what is this? How is this bottom-up processing? Let's put this in conceptual terms. So let's say that in our mind, in our dark mind here, we have knowledge. And knowledge is going to be represented by these strings of lights. And this is basically everything that you know, everything that you have internally represented in your mind. So this is everything that you've learned, either formally through education or experientially through just living in the world. This is what you built up when, as a baby, you crawl around the world and you explore and you touch and you basically put in those pathways and reinforce those pathways that are good and useful. So this is all the knowledge that you have that you can apply to any particular situation. And then just under that, we have your perceptual system. And this is where you take that stimulation from the external reality and somehow put it together into some internal experience that hopefully matches that reality. And in this case, we then have the stimulus, and the stimulus is now at the bottom of this schematic. So we have the stimulus, and this stimulus is that external reality that causes the stimulation of the senses. And the idea of bottom-up processing is that in order for your perceptual system to come to a perception, to come to a conclusion about what is out there in the world, it's enough that you get information from the stimulus. So in order to perceive that there are two animals in this photo, we don't need anything coming down from the top in order to come up with that correct answer that yes, there are two of these particular animals that are out there in the real world. Similarly, if we asked you, are they multicolored? Even if you don't know what brown is and you don't know what white is, you can still say, oh yeah, no, it's not one color, it's two colors. So there are certain things that come up just from the stimulus into your perceptual system, require no knowledge whatsoever in order to come to a perception of that external reality. All right, so that's bottom-up process. The opposite of that, or the other side of that spectrum, is top-down process. And this is where information for perception, in addition to the stimulus that is stimulating your senses, that makes it perception, but in addition to that, and some would argue that a vast majority of the information for perception comes from your high-level knowledge. And in this case, knowledge is considered to be the top. So you have that structure again. Now, in order for you to perceive things, not only do you need that stimulation, but you also need high-level knowledge coming from the top. So I'll give you an example of this. We're going to go to another illusion. So I will show you an image, a cartoon image, and I want you to determine what is it that you see in this image. All right, so how many people see a young lady in this image? All right, how many people see an elderly woman? Okay, so we have some people see a young lady, some people see an elderly woman. For the people that see an elderly woman, can you see a young lady as well? Okay, so we have some that can see both. demonstration kind of failed right now, but if you could not see both, if you saw the old lady, old woman, but you could not see the young lady, then if I gave you extra information like this, if I said, well, here's some extra knowledge for your top down processing, this is the orientation, this is a non ambiguous version of this image, that's the orientation of the young lady, then the people who saw the elderly woman would now be able to see the young lady because of that top-down information. They would go through top-down processing and they would say, oh, okay, I see it now. She's looking away. And okay, that's the orientation there. So now I can see that young lady. How many people saw a young lady in the beginning? How many of you can see an elderly woman? All right, well, some hands went down. Excellent. Okay, so for those of you who put your hands down because you do not see the elderly woman, there's a less ambiguous version of the elderly woman cartoon. So in this case, I'm giving you top down information that the necklace, the choker, is actually the elderly woman's mouth. The neckline is actually the elderly woman's chin. The jawline of the young lady is actually the elderly woman's nose. The ear of the young lady is the elderly woman's eye. So when you provide that top-down information, if you couldn't achieve that perception before, you were then able to perceive it in whichever way you were not able to before. So if you could not see the elderly woman, a little bit of information, and all of a sudden you're like, oh, there it is. Now I'm getting that internal experience of that external reality because that's how we talk. And then if you couldn't see the young lady and I showed you the picture on the left, then all of a sudden you're like, oh, now I got that top-down knowledge that I needed to bolster the stimulus that's coming up from the bottom. So this is an example of top-down processing. And in this case, we have the stimulus, and that stimulus, once again, sends those sensations into your perceptual system. But this time, it's not enough. It's not enough to come to a conclusion about what it is that you perceive. So we now need knowledge to come from the top down in order to supplement or add to the knowledge that came up from the stimulus. And then once that knowledge comes from the top down, where I give you information like, oh, the choker is the mouth, the ear is the eye. Now, when you have that knowledge coming from the top down, all of a sudden you're like, oh, yes, okay, there is that elderly woman. Now I get that correct internal representation, internal experience. All right, so any questions on what bottom up and what top down processing is? Okay. So we are going to wrap up by taking a look at the debate between how much of perception is bottom up versus top down. So this was a very, very important. You can hear the kind of chuckle in my throat. It was a very, very important debate historically, and as it turns out, it's one of those both and situations. But more importantly, is how do the two interact, and what is it that determines whether or not you're going to resort mostly to bottom up processing, or whether or not you're going to resort mostly, or whether or not you need to supplement it with a lot of top down processing. So let's go through a few more examples that'll help illustrate this. The first one is going to be a painting by Al Help. So I'm going to show you this painting on the next slide. And it's a painting of a very common object, something that you have all encountered, something that most of you have probably encountered today. In fact, I can tell you without a doubt, you have encountered it today. So with that being said, I will show you the image, and put your hand up once you kind of know what Al Help has painted. All right, I'll put it on a black background. So hands up once you think you know what it is. Okay, we got 2. Keep your hands up. I'm going to give you a little bit of information. I'm going to help out your top-down process. I'm going to give you the title of this painting. This painting is called The Big N. Now, hands up if you can see it. Okay, we got some more. I'm going to give you some more top-down information. Here we go. If I was drawing this N, I would start down here, go all the way up there, and all the way down here, and all the way up there. Right? So we got an N there, there. It's a big wide N on this black background. How many people can see the big N now? We got some more. Okay, so we started with this stimulus here. Incidentally, did anybody guess it was an N? Yeah. All right, so we had one person that was able to bottom up this and basically say, okay, I can figure it out, that's an N. Everybody else needed extra information, needed that top-down knowledge to help you process this. So you needed to know the title, it was the big N. If that didn't work, you needed to be shown the spatial relations of the size of the big N. So this is an example of something that is predominantly top-down. And this is basically an art piece that is designed to be mostly top-down processing, right? So it was contrived, it was made by Health, but this is definitely top-down processing because we just saw it live here. Almost nobody processed this from the bottom up. Even those that processed it from the bottom up probably relied on the information that it was something that you had seen as a very common object. But the more information you were given about it, the more individuals were able to say, oh, okay, yeah, now I see, I'm getting that internal sensation of the external reality. All right, so that's one example, mostly top down. Let's take another example. So here we have a pencil that has been placed into a glass of water. And how many people perceive this pencil as being bent? So we all know it's not. Right? This is not a funny, weird pencil. But how many people kind of see the pencil as either broken or bent where the water line is? Okay, great. I sometimes ask this because there are cases where I'm worried about the vision of my students, and when they don't react, I'm like, you got to go to an optometrist like today because something is fundamentally wrong. But basically, this is an illusion, very common, where you put a straight object into water, and the part that's in water will look to be at a different position than the part that is in the air, and that is just something that you might have seen in elementary school. This is happening for a very specific reason. So everybody here basically said, yeah, I see the stick is being bent. I see the pencil is being bent. That is my perception of events. What I'm going to do now is I'm going to give you a little bit of top-down knowledge. So much like I did with the big N, I'm going to give you some top-down knowledge, and we're going to see if we can now match your internal perception, your perceived truth, with the external reality of this not being a broken pencil. So the way that this works is you basically have, here we have a schematic, we have the pencil, and you can see that the actual pencil is straight. The external reality of the pencil is straight. But what is happening is that we are getting light being reflected. We'll start off at the bottom of the pencil. We have light that's being reflected from the bottom of the pencil. So that light is being reflected from the pencil. And when it reaches the surface of the water, because the water and air are not the same medium, because the water is more dense, it will, it's been a while since I did physics, basically you get refraction at the interaction between those two medium. You get refraction where the air intersects with the water, and that bends the light. So we have the light coming up, we have the light coming up in the water, it's going straight, but once it reaches the threshold between the water and the air, that bends the light, and the light bends, now in this case, towards your eye. What happens then is that your eye assumes, because this is how our perceptual system is built, your eye assumes that that light traveled in a straight line. And it then perceives that light as having come from that point right there. And the only way that that light could have come from that point, now and why, is if the pencil is actually bent. So again, if the light traveled in straight lines, the only way that could occur is if the pencil is actually bent. However, the pencil is not bent. It is straight, and what is occurring is that the light is bending because of the refractive index difference between water and light. Any questions on the physics of what's going on? Everybody clear on the idea that the water has bent the light rays, and that your mind then assumes that the light rays were straight, and that's why you're getting that incorrect perception? We're good? All right. So what I want you to do now is I want you to take all of that knowledge that I just gave you. I want you to top-down process the image that I'm just going to show you and perceive a correct external reality. Take all of that information, much like the big N, take all of that information, and we're going to correct our perception so that we see a straight stick. And hands up when you can see that straight pencil. There's no straight pencil. There's no way that you can do this. It's impossible to do. So you could get a physicist in here with a PhD in light refraction. They see a broken pencil. All of that top-down information is never going to work in making you see this as a pencil that is straight. You will know that it's a pencil that is straight. You will be able to say, oh yeah, no, I know it's a straight pencil. I understand. It's definitely not crooked, but it is impossible for you, even with a PhD in light refraction, to apply that top-down processing to this bottom-up stimulus. So this example here, this is an example of just about predominantly bottom-up processing, right? In fact, it's bottom-up processing that is resistant to any top-down processing. So this is a very clear example where that stimulus is the bottom, and the information for your perception, incorrect as it is coming from the stimulus itself. All right, one last example here, and this is another painting, and this is a painting of those animals, those two animals that we saw before. This is a painting of the same animals, but now I'm not going to ruin how many there are. And what I would like for everyone to do is to raise your hand when you know how many of these animals are in this picture. Okay, so as soon as you have an idea, don't yell it out, but as soon as you have an idea, raise your hand, and we'll move on with the demo. Are you ready? All right, so we're getting a majority of the hands up right now. So first thing to notice this is not at all as fast as the photo, right? So the photo of the two horses, that was basically, well, I did ruin it, but basically everybody was like, oh yeah, two horses. How many people here, put your hands up, see at least three horses? So three or more. How many see four or more? We got five or more. We got six or more. Okay, so the actual answer is five. So I saw some hands go down when we went from 4 to 5. So if you are unable to see the 5 horses, what you want to do, easiest way to do this is you count the legs and then just divide by 4. It's a tough crowd. All right, so the easiest way to do this, I'll kind of point it out. There's the face of one horse. Right, so we got one horse face. There's another one right there, so that's number 2. We got this guy up here, that's number 3. We got this guy down here, that's number 4. And then we got the little baby horse right here, that's number 5. So we got 5 horses. 1, 2, 3, 4, 5. How many people can now see 5 horses? We got everybody? Okay. So this is a very nice example of an illusion. So this is Beth Doolittle, and she does these types of paintings. This is one where it is kind of a mix between the two. This is kind of, somewhere in between being on one side of bottom up versus the other side of top down processing. So there was a lot of individuals here that got to 5 horses all on their own. Notice that it took a while. So you were probably on your own top down processing as you went through, this, and you were probably saying to yourself, okay, I'm going to do some probably serial processing of this image and look for horse faces, look for the hooves, look for, things that allow me to navigate through. And then for those individuals that weren't able to see the 5 horses, once I explained it, everybody was like, oh yeah, there's the 5 horses. I get it now. So it seems to be a very, very kind of even mix between, okay, this is a lot of bottom up processing is going on. However, there also seems to be a fair amount of top down processing going on in the same picture. So last thing we're going to take a look at. Why are some stimuli mostly bottom up versus top down? Why are some stimuli mostly top down versus bottom up? So if we were to put these 3 examples on a spectrum, we would have Doolittle's Pintos in the middle, and we would have the pencil in the water as being the most bottom up. So we got bottom up on the left here. So that is the most bottom up. Next on the sort of spectrum between these two would be Bev Doolittle's painting. And then the most top down image would be the big N. So the question now is, can anybody sort of deduce, theorize, want to speculate? What is it that determines whether something is going to be bottom up or predominantly top down? Yep. Context? In what way? Okay, so for top down, you have to understand what you're seeing first before you understand it. Any speculation as to why that is required? So what is it that is making you need to understand something before you can see it? Any ideas? Yep.
At least in this example, the is very realistic and yeah, but the top down is very abstract and the forces are kind of
Okay, so the bottom up is very realistic, which gives you a lot of context, gives you a lot of kind of, I don't want to give it away, gives you a lot of context, whereas the top down ones barely give you no context whatsoever. So that means that you need to put in a little bit more context. What's another way of saying that kind of context? What is context when you boil it down to the way that our mind processes stuff? What is context in effect? It's detail. What's another word for it? So think back to our discussion of change detection when we had the one picture that was definitely Jim, and then we had the other picture that was not definitely Jim, right? That's also an example of top down versus bottom up. So if I showed you Jim and you knew who Jim was, you take a look at that picture and say, oh yeah, that's Jim. If I showed you the stick drawing face of Jim, you'd be like, who's that? And if I said, oh yeah, that's Jim, you'd be like, well, if you say so. So what is, we have context, we have detail. What is in our mind? What is the basic unit of stuff that we're talking about? So we're able to go bottom up on this because we're able to process context. We're able to process enough detail. We're able to process enough, almost there, information. I saw somebody mouth the word. Thank you very much. We're able to process enough information. And that is the basic answer of when some stimuli are mostly bottom up versus when they're top down. So you can see on the left side there is a ton of information in that picture. There is shading, there is differences in contrast, there is translucent. When we go to ecological psychology, there is a ton of structure in that painting. There is a ton of information, sorry, in that picture, ton of information in that picture of the water and the pencil. So as we're processing the stimulus, it basically just on the information that is presenting us alone gets to that threshold where we're able to perceive what it is that's out there in that external reality. For the big N, that basically has no information. It's almost completely devoid of information where it's just a big white square, right? It's just a big white canvas. It's got two small little triangles. So if you take a look at the amount of information in the big N compared to the amount of information in the pencil in the cup, the big N has basically zero information. So it's no doubt when our visual system is processing it that from the bottom up, there's just not enough. There's not enough information for it to process to come to a conclusion. So it requires that top-down processing. It requires that extra information. And then the one in the middle with Bev Doolittle's Pintos, that one has a lot of information. But the way that it makes things difficult is by giving you ambiguous information. So you'll notice that the horses, their brown and white areas are the exact same color as the background, as the snow and the rocks. So every single time you see a brown region, you need to process, is that a rock or is that a horse? Every time you see a white region, is that snow or is that a horse? And that takes a lot of information processing. Now there's enough information there, which is why many of you, when I said, well, how many animals are there? Eventually you were like, yeah, there's 5. I can see 5. I've solved it correctly. But it took a while because you have to process that information and you have to categorize it as, okay, this white splotch, that's snow. So I'm not going to count it. But this white splotch, that's a lamb. So that's part of a horse. So let me, work through some more processing. So basically what it boils down to is that if there is enough information present for perception to occur, you don't need top-down processing. It can almost be completely bottom-up. And that's one of the reasons why babies are able to navigate our world. Babies have very little top-down knowledge, and yet you put a baby in a room and let it crawl around, it's not going to run into stuff. It's not going to bang it. Well, it's going to bang its head on low tables, but it's not going to like run into the wall, right? It's going to be able to navigate through its world because there is enough information in that world in order to support the perception that the baby needs to navigate. So whether perception is bottom up versus top down, it's almost the wrong question to ask. More importantly, it's when is it bottom up versus when is it top down? And one of the large determinants of bottom up is that if you have enough information, perception is going to be bottom up. And if you don't have enough information, perception is going to be top down. And this is going to come up when we take a look at ecological psychology and ecological perception, because when perception started, when psychology started, let me back that up. When psychology started, it was a very new science compared to other sciences. So you had physics that had been around for thousands of years. Very incorrect until Newton came along, but basically it had been around for centuries. You had chemistry that had been around for centuries. You had biology that had been around for centuries. And then all of a sudden you had psychology come in. And psychology came in and basically said, hey, we're going to study the mind. We're going to study the human mind. And we're going to study human behavior. And it was an uphill battle. Rene Descartes, the I think therefore I am philosopher, basically said that you can study the mind of an animal because animals are just all reflex, but it is impossible to study the human mind. You cannot. He basically said, as a starting point, psychology cannot be done. So when psychology actually started becoming a science, one of the things that they did was they kind of looked for respectability. They looked for ways that they could go to the scientific community and say, oh, hey, we're not an out-group science. We're an in-group science. We're just like you guys. We're for real. We're not magic and mysticism. we're actually real science. And one of the ways that they did that was they took the concepts and they took the tools from the sciences that already existed and they applied those to the human mind. And one of the areas that they took from was physics. And in perception, they said, we're going to take the ideas and the concepts that you have in physics, so that when they show up to the science club, they can say, oh, hey, we can come in because, hey, look, we're using points and we're using lines and we're using mathematical equations, just like you physics guys. So we're for real. And what happened, and we're going to see this, is that they started with a framework and with a conceptual starting point that did not provide perception enough information. So when we started trying to understand perception, we took from physics, and because of that, we made representational theories where basically there was not enough information coming from the stimulus itself, and therefore early theory said we need a ton of top-down processing to make this story make sense, to make perception make sense. What happened later, as psychology went into its teen years and we got a little rebellious and we got a little more confident in ourselves, is that we basically said, hey, you know what, maybe physics was the wrong concepts to pull from. And maybe we should try to figure out new concepts. And we're going to see a scientist called J.J. Gibson that basically said, hey, you know what, instead of all these idealized mathematical equations, let's take a look at what's actually out there in the real world. And when he did that, perception almost became entirely bottom up. And it was easy to solve a lot of these problems that were very, very insurmountable when you use the wrong concepts. But that is all a spoiler for what we're going to be coming up in the next few weeks. But other than that, any final questions? All right, that is it for today. So thanks for joining me and have yourself a great weekend.